everyone, my name is Omar Kamo. I'm a PhD student, and today you will have together a lesson about SAP2000, and it will be divided into two parts. The first one is how to get started with SAP and how to build your model, and the second one is about how to apply the methods of analysis to your model. So we will first build the model and then we will apply the analysis methods. So we will go over 4 files, in fact. The first one is a Word file. But first, you don't have to worry because I am recording the session video and I will distribute it among you. And all the steps are written down. So if you missed something, you will refer to it later and you will have it recovered. So this is the first file in which I put, it's also divided into two parts. The first one is data about the model that we are going to build. For example, here we have the dimensions of the structure of the planar view. Here's a planar view divided into frames. We have frame structure, 3-story frame structure. And here's the side view. We'll use these data in order to build the model itself. And here is the load that we'll apply in our model. And then the material, because we'll need to define material as well. Seismic information in order to build a response spectrum. Some tables that you might use. And also in the second part, I put some assisting material for you. For example, how to compute the model mass, because SAP needs model mass in order to calculate the mass matrix. So we need to define it, and here is everything about it. And then load combinations. I assume you already know that we have different load combinations. For example, the first one is the ultimate limit state combination, or ULS. This is used for gravity load design. But this cannot be used alone. This should be combined with some earthquake forces. Unless in your region you don't have earthquake, but we assume that in Italy it's full of earthquake. So this should be combined with earthquake loads. Okay, this is the first one. And then we have serviceability limited states, or SLS. As you know, we have 3 of them: characteristic, frequent, and quasi-permanent. I just wrote down the equations so you can refer to them easily. And here's some example about how to combine, how to zoom, okay. About how to combine the different equations. All right, so you might go over it and it will help you. And lastly, we have the lateral combination or earthquake combinations. So earthquake forces, you know that we have to combine them with some gravity load, and here's the combination. E is the earthquake action, and then we add some gravity load, some dead loads, and the live load multiplied by certain coefficient. And this coefficient, you can obtain it using some tables, which I already included in this file. So you may refer to this file. It will help you throughout the course of the exercise. All right, and here's an example of how to combine the different cases, because we do have different cases. Here are the tables that I told you. And at the end, the combinations cannot be used as they are. We have to make envelopes for them. We have to combine the different load combinations in order to have the envelope, which will be used for your design. One envelope for SLS, rare combinations, serviceability. This is used to, for example, to check slab deflection. One for SLS gravity, but this time quasi-permanent, to check long-term effects, such as creep. And one for SLD lateral combination, for interstory drift, and one ULS gravity, the very first equation I told you about, but combined with SLD lateral combination. Yeah, this is to design the members, of course. So you might read it, this document, and you will have a clearer idea about that. And response spectrum, equations, and explanation, everything. So this is just for you guys. And we'll use it a little bit through our exercise. I will keep it here. All right, so we still have 3 PowerPoint presentation. Yeah. Okay, so then we'll move to the other presentations. We'll start with SAP Part 1. In this presentation, we will see how to get started with the models, with the basic commands, and then we will build together our model, but we will not apply any analysis, so we will just build the model, all right? And then in the second part, we will apply the analysis methods, okay? So first part we build model, and second part we apply analysis method. And in this file, I explained a little bit about the different analysis methods that we could apply. We do have 5 methods, in fact, and we'll go over them later on. What I would like to start now is to how to build your model from the very beginning. So of course, you open SAP. All right. So we'll follow the document as it is, all right, step by step. To build your model, you have to click on File and then New Model. And here's File, and here's New Model. You'll have this view, okay? I already put some screenshots so you can expect what you will have, all right? And then choose the unit, which you can change later. So don't worry if you forgot to change it, to put the correct unit. Later on, you can change it. In our case, we'll use kilonewton and meter because those are the units in this file. We already saw them in the load. We have kilonewton and meter. Then choose the type of structure. We have 3D frame structure, so this one. And here they ask us to put the number of story and number of height because I prefer not to put them now. I prefer to put them later because we have different story heights. So if we fix it here, then it's nothing. We'll have to set it again. So I prefer not to do that. And also I prefer not to put any section properties here because we have different section properties. So we just click OK. And you will have initial model. What you will do is that you will delete it. Okay? So set number of story, we will not do that. Don't define beams and columns. Click OK, and we are here. So we are in the step 2. Building geometry.
Sorry, what you have canceled?
I canceled the members because SAP usually assign default section properties to the model. I don't want them. Yeah, you select everything and then you click delete. Okay?
Ha cancellato tutto quello che aveva delle caratteristiche rimasto prima.
Yeah, no, even this one, what remains is grid lines. Grid lines are nothing, are just something to build on, to help you build. But we will also adjust them because it's not our configuration. So guys, the second step is to build the geometry. Click define and then coordinate grid, which is here. So this is the default one. We will modify it, right? So we'll click modify, show system, this one. And then we'll adjust the geometry. Let's open the file in which we have the geometry. So in the x direction, we have 4 grid lines. The first one starts at 0. Okay, so we have the coordinate system at this point, the origin. And then the second one at 4.85. And the third is 4.85 from the 4.8 from the 4.85. We should insert here a cumulative number. So we don't put 4.8. We put 4.85 plus 4.8, which is 9.665. Yes. It's clear? And the last one is 4.85 ahead, plus 4.85. 14.5. So this is the x, in the x direction. What about the y direction? The first one from 0, because this is our original point. So put 0. The second one is at, if you can see it, it's 4.7, all right? And the last one is 9.4, because 4.7 plus 4.7. What about z? Let's see the elevation. 0, 3.5, 3.5, and then 6.5, and then we don't have another one. What do? We add. We call it Z4. It's 9.5. Okay? So we are done. We click OK and OK. And this is our grid line. Okay. But here in the y direction, we don't need to put the grid in the first level. So we just delete it. We start 4.7 and 9.4. Sorry. In the z direction, we don't need to put any grid line in the first floor, in the ground floor. So we remove the 0. So here what we are left with. Okay, guys? All right. Is there a problem? Yeah. If it's Italian, you put Tom. Okay. So. So you are with me now? All right. I'll continue. So now we build the geometry. So we finish the step 2. We go ahead and apply step 3, which is define material. We need to define material before we apply it to our sections. Okay? So click define, and then material, and then we don't want this material. They are default, so we are going to build our new material. So we'll click on add new material. Okay, so as we are in Italy, we put Italy here, the region, material. We start with concrete, and then we will define the steel. Let's see the material that we have in this file is C2530. We just put C2530. and we go. If you want to see the characteristics, you can go inside by clicking on Modify Show Material. You could change the name, you could change whatever you want. But here I would like to point this, that the modulus of elasticity by default is 31 million, right? So what we need to do is that we have to reduce this value, because usually we allow some crack to concrete in order for the steel to work, all right? So this value is as recommended by the Italian code and by other standards. It should be reduced by 50% or a little bit less. In this document, I reduce it by 70% because I don't refer to the Italian code. But I also put it here, 0.5 to 0.7. Okay? So we need to change this value. Just want to see it. It is 22 if you multiply by 0.7. Okay, this is the only thing that we will modify. So we define the concrete. Now we need to define the steel. Also new material, Italy, but now we will not put concrete, we will put steel. According to NTC 2008, which everybody knows, right? And also let's see the steel, we have S355. You will find it, it will be a default. You click OK. You can modify or see the characteristic, but we will not change anything. We'll keep it as it is. Okay, so we went over all of these steps. We don't need to do anything now. We define the material, we have it. Step 4, we'll define sections. So let's see what are the sections that we do have. For the beams, we have 30 by 60 for all the beams. And for the columns, we have 2 sections. At the ground, we have 35 by 35, and then 30 by 30 for the above stories. So 2 sections for the column, and 1 section for the beam. How do we do that? Define section properties, frame sections. Define section properties, frame section. This one is by default, we will not use it, we'll use our own that we'll define now. So we click on add new property, right? Click add a new property, where we have concrete, so concrete and rectangular section. And don't worry if you miss some steps, everything is written, and also I will give you the recording at the end. So we will name it C, or this is beam, right? Beam B, 60 by, how much was it? 30 by 60. Of course, 60 is the depth. So depth 0.6 and with 0.3. Click on that to update. The material we already defined, right? So we click on the material and it's C25 by 30. Easily. And steps are here. Now for the concrete reinforcement, of course, if you are doing linear analysis, you don't need to define concrete reinforcement. But as you remember, we are going also to apply some nonlinear analysis, such as a pushover. Okay, so I will define them now. Those are only for nonlinear. Okay, so material S355. However, it doesn't change here because I might have problem with my software. Okay, but this one should change to the materials that you have already defined. And here is the number of bars. I'll put size is 5 here. All right, and this is okay with me. You can refer to the manual in order to find more information about these data, but for now it's not very important. I will click OK. So everything is defined, and here's your section with the size of reinforcement, with everything. So we are okay with the beam. Now we move to the column. Do I need to go more slowly? It's okay. So now new, concrete, rectangular. Let's call it C1. What are the dimensions on the ground? 35 by 35. And here's our section. Material C25 by 30 as well. Concrete reinforcement, I will just reduce a little bit to number 7. This is C1. This one? Ah, this one? Okay, sorry. Here? Guys, number 7 is the diameter of the bar. Okay, so if you click here on the plus, you can see the conversion. I put number 7. It means bar area, this one, and bar diameter, this one, in meter. So it's 22 centimeter, 22 millimeter. Okay, this is number 7.
How you have how you need the reinforcement now?
Okay. It's written in the slide, but I clicked on the concrete reinforcement here. Okay, guys, the number of bars, you should have it, and the number and the size of bars, you should have them from your preliminary design. Okay, there are some formulas that gives you preliminary data, and then you will check them if they work or not. But here I just assume. It's okay. And then you go out. All right. Now we need to define the other one. Instead of creating a new material, a new section, what we can do as shortcut, and also written in the slide, that we click on the one we defined, and we say add copy. So we added a copy of that one. This one we'll name it C2. Okay? And we will adjust the dimensions. So now we have another section. It's C2, but we didn't build it from the scratch. We copied from the one that we have built before. So if you notice, we went over all this stuff. Give your section a name, define reinforcement. If you have more than one section type, define each one independently. If the sections are similar, add copy of the property. So we have just applied that. So we finished step 4. Now we move to step 5. We need to assign section. Now we have the properties and we have the material. So we need to build the model. How to build the model is that we click first on the draw. It's written here. And then another time we click on draw frame. Draw frame. And then we have this view. So we want to build, draw the beams first. So we choose beam, B30 by 60. And we just draw on the grid line that we built. It's important that you use some shortcuts and to use the different views that SAP offers here. I'm not sure why I don't see it, but you can switch between views using these commands. For example, what? All right. Okay, sorry. 3D, and here we click, and then, yeah, you're right. Thank you. So the best way is to build beams is to look at the plan view. The plan view is XY. And yeah, I come.
You select on the right side of the window.
Yeah, and then
XY.
Guys, do you see that blue rectangle?
Quella specie di rettangolino blu nella visione tridimensionale che rappresenta il piano sulla destra.
So we can move up and down using these buttons. Okay? This will make it really easy for us. So now we are on the first story because you see the blue rectangle. So as we said, draw frame, and then beams. So we will just connect nodes to that one. You don't need to unclick, you just continue. Okay? So we are building the beams.
We are at the first floor.
At the first floor. How to release it? By clicking on the right click of the mouse. Okay? So now you can start this right click to release, left click to assign. Okay, so we continue and draw all of our beams.
Lui dice che cliccando col pulsante di sinistra si rimane sempre attivi nella definizione degli elementi. Se invece si clicca col destro ci si scollega dalla zona politina.
So we drew the beams on the first floor. We move up using this, and we draw on the second story.
It is important to don't define two elements on the same point of the grid. Yes, because you define two elements at the same position. It is necessary to define only one for each frame, for each part.
Yeah, of course. If you have a joint, you have to stop at that joint. Okay, in order to, if you want to result at that joint, in order to connect columns with beams. If you don't have a joint, then you cannot connect. So we have our beams, now we build the columns. Now to build the columns, it's better to change the view. So let's put it XZ. Okay? And if you can see the blue rectangle, we are moving. Now, C1. C1. Guys, I think we forgot to define the third story, but we can adjust that easily, all right? We go again to define and coordinate system grid. The way we did at first. Okay, I will remove the column and we'll start the column from the beginning. Okay, so we have now the correct number of stories. Again, draw frame, C1, 1, 2, 3. Every time you have to click on the right click to release. And then again. This for the first story. For the second and third story, we have C2. Because we have different sections. 1, 2. 1, 2. 1, 2. Now there's one shortcut that helps you replicate what you have built in order not to move again and click on everything again. So you select your columns. I wrote that here, draw only one frame and use the duplicate command. Okay? And that's what I will be doing now. So we select the columns and we go to edit and then replicate. So we need to go in the Y direction. How many times? 2 times. Because we need to replicate 2 times. What's the distance? 4.7. So we write in the Y direction 4.7. So they are replicated now. We have them in all the building. And we didn't draw them again. So we just replicated. Okay, guys. But since we have missed one story, we need to draw the beams again on that story. So I will adjust the view, XZ again. Sorry, it's XY. And we go to the first story. Here it is. We draw the beams again. So we have everything. If you can. So now we assign the section. We have our building already built. Now we need to put some support at the base. Okay? Select the nodes, the base nodes. You can select them one by one in this way, but it will take time. So we just move in the low story. This is the ground floor, and we just select them in this way. Now how to assign the support system? Click assign nodes, joint, sorry, I wrote it node, but it's joint. And then restraint. You will have this view, and you will have also here the screenshot. We have fixed support. So we don't need to define everything. We have the picture, so we can just click this one. We block all movement, and then apply. So you have the support. Okay? And then in the step 7, this command is very, very helpful, so never ignore it. If you are dealing with very complicated building, it's very important that you group your elements. For example, you group all your frames, first frame, second frame. So you can call it by just clicking on that group. And I will tell you how to do that. For example, let's group the frame. The first one. Here it's called frame G, okay, in which plane? In the XZ. So here XZ, and see the blue rectangle, we are at it. You click all, whatever element you want to include in that group. If, for example, you just want the beams, okay, so you click on the beams. You have the beams of the first frame, frame G. Now, to group elements, select the element that you want to group, assign, and then assign to group. Here it is. Define group. Here we define the group. Add a new group. Change the name. Okay, frame G, only beams. You can create whatever group you want, according to how convenient you are. And we click OK. We have beam G beams, frame G beams. And then you apply. Now, if you want to recall it, if you want to select this group, what you do is select, and then select another time. You can select by properties. So all elements that have this property, I want to select them, or by assignment, or by group. So what we do, here is the group that we defined. And then we select. Look, it's selected. Okay, so again, it's select again, and by properties or assignment or whatever you want, but in this case, by group. And you select. And one important shortcut is that you can find here. The first one is you select all your structure. The second one is you select your previous selection. For example, you selected this beam, and then you released it. And then you want to select it again. What you do is you click on this one. This is very important. Try to use this command. And then if you select multiple elements and you want to release, you click on clear. Nothing is selected. Okay, this is just for you guys. So this is how to do grouping. Now we need to define diaphragm. Why diaphragm? Because usually, especially in concrete, reinforced concrete slabs, we don't define the slab because numerically it will be very exhausting. It will take time. So we don't define the slab itself, but we define its behavior. We know in concrete slab do not move in plane, do not really deflect. So we select all the nodes at that story and we assign diaphragm. We say that I don't want out of plane deformation at all. I want all the nodes to move in the same plane. So in this way, we save a lot of time, computing time, but we preserve the behavior of the slab. Okay, how to define slab diaphragm? This is short description about diaphragm and why we do that, and here how to do it. How to click on assign, joint, you are following, and then constraint. Not restraint, but constraint. We don't have nothing, okay? So we need to define new. Define joint constraint. Here it is. Choose constraint type. So what type we said? It's diaphragm. We have multiple types, but we are interested in diaphragm. Diaphragm. And then add new constraint. And give it a name, diaphragm. Here's the important thing. You don't define one diaphragm for all your model. For each story, you have to define one diaphragm. If you define one diaphragm for all your building, then the nodes at different stories will be connected. And this is one very common problem. Then you will not know where's the problem? So you have to prevent that from now. However, there is here command that say assign a different diaphragm constraint to each different story. But I will not use it now. I will define 3 diaphragms. Diaphragm 1, and then diaphragm 2, constraint axis, Z axis. Okay? Z axis. This is by default. And diaphragm 3. Because we have 3 stories. And then okay. And I wrote that note here also, yeah? For each floor, select all, okay. One diaphragm for each story. Now how to assign diaphragm? Now for each floor, select all nodes. Okay. So in which plane we are X, Y, because we want to see the floor. So X, Y. We are at 0 floor, at ground floor. We don't assign diaphragm here, only for slabs. So we move one floor up. See where we are in the first story. You select node by node, or you select everything, because the diaphragm will be assigned to node. If you select beam, it will not assign any diaphragm. So you can select everything, just to save time clicking on the nodes. And now let's follow the slide. All nodes here, grouping. Okay, I wrote here that grouping is important and stuff. Assign, joint, constraint. Assign, joint, constraint. Because we entered into joint, this will only be applied to joint. It will not be applied to beam. That's why we selected beam for nothing. So first floor, first diaphragm, apply. We don't need to go out. You just go one floor. Okay, so we are at the second story. We do the same. But now we don't assign the first, we assign the second one. Apply. And then the third one, but also always check that you are on the correct story. With this blue rectangle, we select and then diaphragm 3. If you want to check whether you assigned the diaphragm or not, whether you assigned a section or not, you can click on the right button here on the node, for example. You have all information. You have the assignment, okay, it's diaphragm 3 and other information. You have the load, but we didn't assign yet load, etc. And also you can click on the structure element. So you have, see, section property, 30 by 60. This is just in case you are lost or something, you can check again if you are okay. Okay guys, now when we define the diaphragm, we move ahead. Here is a screenshot of what windows you expect. And then we have to define the loads. How to define the load? The first step to do is that you have to define something called load pattern. How to do that? You have to click on define and then load pattern. You will have this window. In slide 12 you will have it. I put it. Okay. So let's check our loads in this file, because all informations are here. We have self weight. We have slab load, because as I told you, we will not build the slab inside the model. We will compute its load, which is given here, and we will apply it into our model. So we will not build slab. Slab load, and then superimpose load. In our case, it's partition walls on the boundaries. And then the live load. On the roof, we have snow. On the second and first story, we have live load coming from people. Okay? So, just in order to have the same names, I will cheat a little bit. So the first load that you have to define is the self-weight of the building. This load will be computed by the software itself. So you will not compute the self-weight because we define the material, so the SAP can do that. Self-weight. Here's self-weight multiplier. If you put 1, as if you are telling SAP, compute the self-weight for me. If you put 0, it will not be computed. So this number should be 1 only for self-weight. Okay? And since we are modifying the first one, we are not building something new. Look, we click on the first one and I just modified the name. So I click on modify. Now we want to insert new load patterns. The first one is the slab load. I call it slab. I call it also G2, just to have reference, just to have comparison with the code, because they call it in this way. It's dead load, but now the multiplier is not 1, because I will insert the load. So I put 0, and I will define later. Now we don't put modify, we put new. It's clear. And then we have superimposed. I call it here super dad. It is G3. It's also dad and multiplier 0. Add the new. Okay, and then we are left with live and snow. Here I differentiate. Although in this table there is under live there is snow and normal live load. But in this software you have to differentiate snow from live. Okay, so live load Q1 live. Also multiplier is 0, and finally the snow, I call it Q2, and you put the type snow, roof live, okay, but there is snow also, okay, so new, and we have all load patterns. So we applied all of these load patterns, okay, and here's a screenshot. And then we move, and we have to insert our load. Because we only define the pattern, we need to insert those numbers. For the self-weight, we will not do anything. For the slab load, we'll insert those numbers. For the superimposed, those, and for the live, the rest. How do we do that? If you notice, we have surface load, kilonewton per meter square. And here we have linear load. How to assign surface load? We have 2 ways. The first way is to apply on the slab, and the SAP will convert this load into the beams. This is the first way. The second way is to compute by yourself how much load will go to the beam, and then to compute this linear load. But I find this a little bit complicated. I don't like it. I go to and apply to the surface, and let SAP do whatever it can do. Okay? But in our way, in our exercise, I put here notice that assume one-way slab in the x direction. So you have to give SAP this command to do, otherwise it will distribute along both axes. But in this case, we have hollow block concrete slab in the x direction, so we want to load only in the x direction. So 2 ways to assign surface load. The first one, on the slab, you have to define a new material and a new section. So it's like we are assigning slab to our model, but with no weight, just to put the load on it. Okay? How to do that? Define section properties. We already done that for the beams at the columns. We'll do that again. Define section properties, area section, not frame section this time, it's area section. Now we continue shell. So it's shell, add new section, and then name, let's call slab, no weight. Everything is written, okay? Assign the material. You can click on plus if you want material, however it will. Okay, so we don't want this material because if we insert C25 by 30, then SAB will compute its weight. We don't want weight. We want material without weight. So we have to define a new material. Add a new material, concrete, whatever you want. Let's call it C8, not 10. But here's the trick. You modify and you put here 0. In this way, there will be no weight for the slab. Okay, guys? You can modify the name as well. Slab, no weight. Any question? From where? Yeah, okay. Okay. You know, if you open this, you have to assign material to your section, right? But your material is not here because all of this material will have weight value. Okay, so you have to define something new. You click on this plus. This is shortcut. When you click on this plus, you define new material. Concrete, you put whatever grade you want. You say okay, and you will have it here new. And then you modify it. You modify this value. If you put 0, then you will not have weight. Okay? So I will also, okay. So this one that we defined, slab no weight. Everything is all right. Okay, as we said, it's shell, here membrane and bending, not really important, but let's see what I put here so we are in the same path. I put 0.2. It's not very important since it will not have any weight. But here don't forget to assign the material slab no weight. And then okay, we are okay. We defined our slab. I will continue from the slide. Click on plus, we did that. Draw rectangular area or quick area. Now we have to draw the slabs. So at which floor we are now, guys? At the third one. Draw. We have multiple commands to draw. You can draw a rectangular area in this way. Slab no weight. Check this always. You connect these two, and you have it. You connect any two opposite points. You have the slab. This is first command. The second one is to the quick draw area. You just click inside. Okay. You move another story and you click inside. Another story and you click inside. So you have all your slabs. And then, so select the slabs you want to assign a specific load. Group and view are important. Assign area load. Okay, now we have the slab. We need to assign the load that we have. So we have the slab load 5.4 at the roof and 6.1 first and second story. 1, 2, 3. This is first story. And we move to the second story because we have same value. So we click them together. As written in the PowerPoint, we click assign and then it is area load. What do you think here we click? Uniform or uniform to frame? Because I said before we want to transfer this load to frame. So we'll click on uniform to frame. Look here, here is one way or two way. By default it's one way, so we keep it. And I will show you how to know in which way, because we cannot here define. I will show you how to check in which way your load is transferred. So what kind of load we have? Slab. So we already defined it, yeah? That's the load pattern. It will be shown here. Slab wave, slab G2, global coordinate system, gravity load, and then 5.6. It was 6.1. 6.1. And we put the direction in gravity direction, okay? Here we have add, we have replace, and we have delete. Since we don't have any load yet, so we click on the add to existing load, okay? If you do have load and you want to change it, so you put the number here, and then you click on replace load. For example, you inserted 5 by mistake. How to change it? You can either delete, or you can just write the number and mention here replace. In our case, since we don't have any load, we can click on add or replace. It will be the same. And we have already selected the first two stories, and we click apply. And you will have here the numbers. Minus 6.1, minus 6.1 in the Z direction. Okay, so we go one step, one story ahead, and we select the last slab. In this way, we don't have 6.1. We have 5.4. So 5.4. Okay, so we assign the slab weight. Now, before we move to the linear load, let's do the live load, since it's already also area load, surface load, and we so we'll assign the live load. 2 on the first and second story, and 1.3 on the third story. You can keep this window open, okay, because we'll use it. Put it here and move to the first story. We're at the first story. We select. And also the second story, because they share the same values. But now we have to change the load pattern. We put as live load. One way as well. Do you remember the number? Because I forgot them. It's 2. Now if you put replace, what happens? The numbers of that load will change? They will not, because we changed the load pattern. Okay? So here, to be safer, just put add. This is the amount of live load. The dead load is still there. It didn't go. Still there. But here, since we assigned a new load, the new load will be shown. And then the last story, 1.3. But we have to select, okay? Don't forget. Everything is fine, apply. So we have our live load and slab load. And we have said that self load is computed by software, so we still have the superimposed, the load coming by the partition wall. But before moving to that, we need to know in which direction we assign, because we need it in the X direction. Usually, you can see the local axis of those slabs. Can you click on this icon, set display option? And then, since we are working with area, you go to the area and see local axis. Okay? Okay. You see the green and the red. You have to memorize that. Load is assigned to the red one. So our load is in this direction, in the X direction. and we want it to be in the x direction, so we are fine. Okay, if you want to change, what can you do is that you rotate your local axis. You can select on the slab. Everything is written in the slide, so what I am doing is written. Let me check. Rotate the axis to change the direction to rotate. Click to rotate the axis. Click on assign area local axis. Let's do that. So we click on the area, assign area local axis. You can rotate by certain degree. So we are 0 degree now. You can put 90 and then apply, and you have them rotated. See? Now for these two areas, the load is distributed in the y direction. But we don't want that. We want it in the x direction. So we turn it to 0 degree. Now they are okay. Our load is distributed in the way we want it to be. We assign static load. Here I mentioned that there are two ways. Okay, and we did them. Now we have to, if you want to assign linear load on the beams, select the beams. Here grouping is important. You can make groups like group for the beams of each story. So you can select that group and you have all the beams selected. In our case, we didn't do that, so we have to select them. Okay. But the load will be, we want the load to be applied only on the boundary. So we don't need those beams. You click again on them to remove. And also the slab. So we have the beam of the first story, and here we want the beam of the second. If you want to click from left to right, you have to put all the elements inside the square. From right to left, you have just to touch it, and it's selected. Okay. Second story, and of course we don't have walls on the roof. Okay, so we don't click on the roof. So assign frame load distributed. What's the pattern? It is super G3, and it is 6 kilonewton per meter. 6. Here you can use it if you want to, if you have trapezoidal load. However, in our case we have distributed, so we will not change. Gravity and force, everything is fine. We just apply, and it's applied. Keep in mind that you have to always save, because sometimes SAP crash and you lose your model. Huh? Okay. You want me to repeat what? How to? The frame load. So you select the beams that you want. Okay. And then you click on assign. And here's the load section. So we are interested in frame load. You go frame load, and what do you have? Distributed. Distributed. This view. You put the load pattern corresponding to the load that you want to insert. It's G3, and then here's the value. And you don't touch this because it's not trapezoidal. And you click on apply. If you want to check, you can, as I told you, right click on the beam and go to the load, and you have, okay, we have super dead. Apply. Also for the slab, you have loads, live load and slab load. Now we have our load defined. Now load combinations. Because the load that we inserted, we should combine it according to some load combinations. We have different combinations, as I said in the beginning of this lecture. Load combination, for example, for the ultimate limit state, for gravity load design. You know this, of course you have seen it. So we'll just insert it. Now, and here are the values according to the Eurocode. Maybe the Italian code is a little bit different. The dead load multiplied by 1.3, live load and superimposed load by 1.5, and then the snow is multiplied by 0.75. You can refer to this file in order to have more detail. Yeah, exactly. Yeah, you know those coefficients. Now you can find them using those tables here, and you will have the value that I told you. 1 second. Those are gamma. I'm not sure. You cannot find those coefficients in those tables, but in other tables. Those for ultimate state, because this gamma is 1.3 multiplied by the gravity load. Okay, by dead load, sorry. And for life, it's 1.5. Let's get back to that later, okay? I don't want to lose time on that. Anyway, so let's try now the ultimate limit state combination. But you can build whatever combination you want, so it's not exhaustive. It's not everything, this one. How to do that? Define load combination, add a new combo. What do you want to call it? Since it's ultimate limit state, so we are calling it ULS1. So it is dead load multiplied by 1.3, add, then slab load also by 1.3, superimposed by 1.5, because we consider that as live as well. Live load times 1.5, and snow, because there is reduction value, we reduce the snow, 0.75. Okay, and we have our the first limit state. And here it is. Okay. Let's say sometimes you have different cases. In order to have, for example, the maximum shear, you have to assign maximum load on both sides of the column. Okay. So if you like to have your critical case, you have to do different cases. And this way you will have different combinations. Okay. So let's say you go in this way, you have to define another one as L2, as ULS2, and here some loads, etc. So then you will have different cases here. Okay, you got the idea. Now before you design, when you run the analysis, you will have result for each case. But if you would like to do the envelope, that you combine the result of both combination together, you have to define another combination. We call it envelope. And you change the load combination type to envelope. And here, new stuff will be shown. ULS1 multiplied by 1, and then ULS2 multiplied by 1, and you have the envelope of those two. Okay, now when we run the analysis, you can see the result of the envelope, and the numbers inside, you will use them for design. So we saw how to define combinations and how to define envelope as well. Now we have the buildings, we have the loads, we have everything. We can run the analysis, but we did not insert earthquake forces yet. So if you run the analysis now, you will have the result of the vertical loads only. You run. So those are the different case names, and by default, it computes the model analysis. However, we don't need it now, and we'll talk about that later. And after you run the analysis, you will have the deflected shape. We see the deflection is in plane because only vertical load. You can see the undeformed shape. You can see the deformed shape using those three. The deformed shape. Now, when we click on the deformed shape, it asks us, according to what? What load you need to see the result of? You can see the load of the result of the dead load, or the only slab, or only super, or ULS1, or even the envelope of ULS1 and ULS2. Let's pick the envelope. And here's the deformed shape coming from the envelope, ULS1 and ULS2. However, you might have different, like 7, 8 ULS cases. And in this icon, you can see the results, the numbers, the shear, the moment, the axial load, everything. According to also envelope and moment M33, which is in plane moment, which is usually the one we are interested in. See, guys? We have the moment on the beam. You can notice that the moment for these beams is greater than the one of these beams. The reason is that we applied the load in the X direction. So they are supporting the load. That's why they are bigger. You can see other results as well, like axial forces. Of course, axial forces are for columns. You can see a greater value at the bottom because it supports the whole building. And then it decreases as you go up. Okay, until this point, we have covered the first part. How to build your model and how to get started and how to build your model. But we have also seen how to get the result due to vertical load. If you would like to take a break, maybe usually how long is it? Like 10, 15 minutes? 10 minutes, all right. So yeah, let's take a break and then we'll start freshly from the second part, is how to apply the analysis method to our model, okay?
Few weeks ago, Sebastiano and Shimano assigned us a project that now they say that we